Chapter 7, Section 2, the ambiguous case of the law of sines. So in 7.1, we dealt with one case, and that case dealt with if we have two angles and a side given. And so in 7.2, in this section, what we're going to be doing is we're going to be dealing with triangles where only one angle is given but two sides. And so we call this side-side angle. So the first term that we need to talk about is ambiguous. Now, ambiguous just simply means that there is an uncertain or questionable amount of possibilities, because there's multiple possibilities when you're dealing with these types of triangles. And if you look on page 313, you'll see where these possibilities come into play. So on the chart on page 313, for example, if the angle that's given to you is acute, then you have four possibilities, and those possibilities are 0 triangles, 1 triangle, if A is equal to your height, or which would be a right triangle, and then the other one where A is actually bigger than B, or equal to, I guess. And then the other one is where you get two different triangles, and again, you can look at those pictures if you want to. And then the other scenario is if if the given angle is obtuse, and if that's the case, then you only have 0 or 1 possibilities. So again, ambiguous just means that there's an uncertainty of how many triangles we're actually going to get, if we're even going to get a triangle in these problems. So what I want to do is I want to go through this. I know this looks like a lot, but this I think will help you. In section 7.1, we use the law of sines to solve triangles involving the cases of side angle, angle, and angle side side. So a good thing to know is that you're going to use law of sines the way that we did if you're given two angles and a side. And again, this is side angle angle or angle side angle. However, if you're given two sides and the angle opposite to one of them, you're going to use side-side angle. So again, you're given two sides and the angle opposite to one of them. The angle opposite to one of them. Then it's possible to have, and this is why it's called ambiguous case, it's possible to have 0, 1, or 2 triangles to solve for. And this middle paragraph is important for you to understand, because this is how we're going to actually solve these triangles. Since you'll be using the inverse of sine in order to solve, and I'll explain to you why in just a minute. For the second angle, it's possible to have two such angles because sine, and this is important, sine is positive between 0 and 180. And so we have to take both of these quadrants, quadrant 1 and quadrant 2, into consideration. So what you do is solve for the angle and then subtract the angle from 180. So the first step in solving these ambiguous cases is to solve for one of the missing angles. And then of course from there we know that we can take it from 180 to find the other possible angle. And we're going to use law of sines to find that first angle. And then what we're going to do is we're going to compare that angle with a given angle to see if they could both be angles in a triangle. And this is going to tell us actually how many triangles we have, either 1 or 2. And then down here, this is important to know as well. This is when you're not going to have any triangles. Pay attention to scenarios that give you sine of an angle being bigger than 1 or less than -1. So in other words, your angle has to be between -1 and 1. Okay, so keep that in mind as well. Okay, so let's put this into action. It says to solve the triangle or triangles if they exist. So the angle that we're given is angle B, and you can draw this out if you want to. Angle B is equal to 48.2 degrees. Side A is 890 and side B is 697. So the first thing that I'm going to do is I'm going to find one of my angles. one of my angles. And since I'm looking for angles, whereas in 7.1 I was looking for sides, and so we did A over sine A is equal to B over sine B, and so on and so forth, but we were looking for sines. Well, in this section, since I'm looking for angles, what I'm going to do is I'm going to do sine B, I'm going to do my angles on top, over side B is equal to, and I'm going to work with A, so sine A over side A. Okay, and so we're going to have sine of B is equal to 48.2 over side B is 697 is equal to sine A, which is what we're looking for, over A, which is 890 centimeters. And so we need to solve for sine A. So when we do our cross multiplication, we're going to have 890 sine of 48.2 is equal to 697 sine A. And so if we divide both sides by 697, we're going to get sine A is equal to 890 sine of 48.2 divided by 697. Alright, and so sine A is going to be equal to, and you're going to get a big long decimal, and so remember the decimal that I'm coming up with is 0.951899053. And remember, this right here has to be between -1 and 1. Okay, so this has to be between -1 and 1. And it is. So we know that we're dealing with some triangles. We either have one triangle or we have two triangles, and we're fixing to figure out how many. Okay, and so to figure out what angle A is actually going to be the sine inverse. The sine inverse of 0.951899053. And so when you put that in your calculator, angle A is going to be 72.2 degrees. Now, so how do we know if we're dealing with two triangles or just the one triangle? Well, remember we talked about sine is positive between 0 and 180, so essentially quadrant 1 and quadrant 2. So we know that 72.2 is in quadrant 1. And so what I like to do is I like to say that A prime is going to be the reference angle. So we're going to go off of the x-axis, which is 180 degrees. So we're going to have 180 minus 72.2, which is going to be 107.8. And so that's going to be your second triangle if it exists. Okay, so this takes care of your quadrant 2. So now we have our possible angles in quadrant 1 and quadrant 2. So let's deal with triangle number 1. In triangle number 1, angle A is equal to 72.2. Angle B, we don't know, but we can find out by doing 180 minus 72.2. 180 minus 72.2 is going to be 48.2. And then angle C is equal to, angle B was given to us. Angle C is going to be 180 minus 72.2, which is going to be 59.6. Okay, so angle B is here. It was given to us. And so angle C is the one that you're going to have to find by doing 180 minus 72.2, which is 59.6. Okay. And so when we add these together, we get 180 degrees, and we have all positive angles. So we know triangle 1 exists, and so we have all of the sides, and notice our directions say to solve. Well, when we solve this, we have all the angles and we have two sides, so we need another side. And the way that we're going to do this, because it's not a right triangle, we can't use the Pythagorean theorem, so we have to use law of sines again. And so we're going to take, or I'm going to take, and I'm looking for a side this time, so I'm going to put the sides back on top. So I'm going to have B is equal, or B over sine B is equal to, and I'm missing C, so C over sine C. So we're going to have B, which is B, which is 697, over sine B, which is sine of 48.2, is equal to C, which is what we're looking for, over sine of C, which is 59.6. And so when we cross multiply, we're going to get C is equal to 697 times sine of 59.6 divided by sine of 48.2, and so we get C is equal to 806 centimeters. Alright, so we need to check this. We need to check and make sure our ratios are coming up properly. So look at this. In this triangle, angle B is the smallest angle. So side B should be the smallest side. Well, it's 697. A is 890 and C is 806. So that checks out. B is the smallest angle and B is the smallest side. So that's good. A in this one is the biggest angle, and if we look at our side lengths, A is also the longest side. So triangle 1 checks out. So there's triangle 1. Triangle number 2. We have angle A prime. We said was 107.8. We have angle B prime, and I'm just calling them prime because I don't want you to get the angles mixed up, is the one that was given to us, 48.2, so that's not going to change. And then angle C prime is going to be the one that we need to find, so it's going to be 180 minus 107.8 minus 48.2. And so C prime is going to be 24. Okay, so again, I know that this works because let me tell you, if you did 180 minus 107 minus 48 and you come up with a negative number here, you know that this triangle would not work. So since we came up with positive numbers on both of these triangles for angle C, I know that both of these are two triangles that are possible. Okay, so to continue solving, the only thing I need to do is find side C, so I'm going to do it the same way. So we're going to have B over sine B is equal to C over sine C. And so side B is 697. Sine B is going to be sine of 48.2. C is what we're looking for. And then sine of C this time, which is going to be 24 degrees. So C this time, when we put this in our calculator, we're going to have 697 times sine of 24, all divided by sine of 48.2. And that's going to come up with 380 centimeters. Alright, so again we need to check this. Angle C is the smallest angle, and so side C should be the smallest, and it is. Angle A again is the biggest, and side A is the biggest, so we know that it works out. So one more time to recap. If you're given an angle and two sides, you have side angle. So what happens is you need to find one of those other angles by using your law of sines. Find one of the other angles by using the law of sines. And when you get down to this point, when you have sine A is equal to a long decimal, make sure that decimal falls between -1 and 1. If not, then the triangle doesn't exist. But since ours did fall between -1 and 1, then go ahead and take the inverse of that decimal, and you're going to come up with an angle, and that angle could be in quadrant 1 or quadrant 2. In our case, it was quadrant 1, and so we used a reference angle and came up with the other one in quadrant 2. So once you have those angles, so now at this point we have two angles, and to find the third angle you just subtract them from 180. When you do this is very important. When you do this, these angles, this third angle that you're finding cannot be negative. No angle can be negative. So if you come up with a negative angle, it does not exist. That triangle would not exist. Alright, so when we solve these triangles, our answers are going to be, we had to find angle A, angle C, and side C, and so that's what we did. Let's try again. For this one, we have angle C, and we have side A and side C. So the first thing I want to do is I want to find another angle, and I'm going to look for angle A because that's what I can find with the side A. And so since I'm looking for an angle in my law of sines, I'm going to put the angles on top. So we're going to have sine C over C is equal to sine A over A. So when I work this down, I'm going to have sine of 82.2 over C, which is going to be 7.62, is equal to sine A, which is what we're looking for, over, that should be a little a. So side A is going to be 10.9, and so sine A is going to be equal to 10.9 times sine of 82.2 divided by 7.62, and so sine A is going to give us this big long decimal 1.417211,478. And so remember, at this point we have to check to see if sine A falls between -1 and 1. And we know that it doesn't because it is 1. It's 1.4 something. So it's actually about 1.5. So it's actually above here. So since this sign does not, the sign of A does not fall between -1 and 1, the triangle does not exist. And you're done with the problem. So again, make sure you check these things. Save you a lot of work. Okay, so let's try this one. Again, you're given an angle and two sides, so we have side-side angle. And again, it's important to know what you're given so you know which case to use, which scenario to go by, which steps to go by. So since we're only given one angle, we need to find another angle. So since I'm looking for angles, I'm going to put that on top again. And so sine of angle C, which is 52.3, over C, which is 59.8, is equal to sine A, which is what I'm looking for, over side A, which is going to be 32.4. So when we cross multiply, we're going to get sine A is equal to, again, it's a long decimal, so it's going to be 0.43001279. And again, at this point you need to check, does sine A fall between 1 and -1? And it does. It's 0.4, which is about a half, so it checks out. And since it does fall in between, go ahead and find A by taking the sine inverse. So sine inverse of that big long decimal is going to be 125.5. I'm sorry, it's 25.5. It's going to be 25.5. Alright, and so what we need to do, this is quadrant 1, and so since 25.5 is in quadrant 1, we need to find A prime, which is going to be quadrant 2. And so we're going to do a reference angle, so we need to do 180 off of the x-axis, 180 minus 25.5, which is going to be 154.5. Okay, so let's work with triangle number 1. So for triangle number 1, we know that angle A is equal to 25.5. Angle B we don't know, but we can find. And angle C is equal to 52.3. So angle B, you're going to do 180 minus 25.5 minus 52.3. And you should come up with 102.8. So I came up with a positive angle, so I know this triangle is going to work. And the only thing I have left to do is to find that missing side, which is B. And so I'm going to put C over sine C is equal to B over sine B. And so C is 59.8 over sine of 52.3 is equal to B, which is what we're looking for, over sine of B, which is 102.8. And so B is going to be equal to 59.8 times sine of 102.8 divided by sine of 52.3. And so B is going to be 73.9. And again, you can check your ratios. So B is the biggest angle, and so B should be the longest side. So this is 73.9, which is much bigger than those, so I know that that checks out. Okay, triangle number 2. I know that angle A prime is equal to 154.5. Angle B prime we'll need to find, and angle C prime is the one that's given, which is 52.3. So B prime, if I do 180 minus 154.5 minus 52.3, I'm going to come up with a negative 26.8. And since no angle can be negative, I know that there is not a second triangle. So this is my answer. So what I'd like you to do is try numbers 13, 15, 17, 21, and 25 on pages 318.